In this video, I'd like to take a look at the concept of process capability, and the specific learning objectives will be different ways to measure process capability, some traditional techniques that we're very familiar with, like percent in, percent out, but then introduce a new way based upon sigma levels of performance. We call it CP and CPK. We'll define what the CP and CPK variables are. We'll spend some time going through how CP and CPK is calculated. Finally, we'll interpret the results of any sort of a CP and CPK analysis. So what is process capability? I'm pulling some of the content directly from the Lean Six Sigma Data Analysis Workbook. That's what some of these slides are right now. And the question, what is process capability, I think can be answered in a short, quick statement. Voice of the customer compared to the voice of the process, or in particular, where voice of the customer is the specification limits that you've identified through customer needs analysis. So we've got VOC is equal to spec limits. And the voice of the process, I'm calling VOP, that's just the historical performance that that process has had over time. That's the data that you've collected historically on how well the process is performing, how good or bad the process performance is. So there are a number of ways that we currently do this when we compare voice of the customer to voice of the process. One common way is to take a look at process performance and compare it to the spec limit visually using histograms and talk about the percent in or the percent out. Another way is to take a look at the number of defects that you've got, where a defect is process phenomena happening outside of spec, and a non-defective or compliant part or transaction is something inside of spec. Sometimes in production and manufacturing environments, because you're dealing with such a consistent process, the way that we count these defects is defects per million opportunities. Another way to take a look at how well your process is performing is to measure the number of standard deviations that fit within inside of spec. We, in the end, call those sigma levels of performance. Examples of sigma levels of performance, I'm operating at a Six Sigma level of performance. Each of these different ways helps compare the needs that the customer has, specs, to the historical data that we've collected on our process performance. How much of it is falling in or out of that specification limit? I like all three of these methods, and depending upon the environment that I'm in, I'm going to rely on one over the other. In service and transactional, I'm probably looking more at percent in or percent out. My audiences just understand that concept better. In manufacturing and production environments, I may be looking defect rates, DPMO, or sigma levels of performance because those terms are used frequently and well understood by my audiences. But there is another way to measure process capability. They call it process capability, but they use a variable designation called CP and CPK. And we'll take a look at this fourth technique for comparing the voice of the customer to the voice of the process. We'll take a look at that next. So I want to dive a little bit deeper in what the term CP and CPK is. What is CP and CPK? And I think the best way to describe it is to start with the following thought problem. Let's assume that you're working in a process environment and you've identified what the spec limits are, and you've measured process performance historically, and you found that over time the defect rate was 3 out of 1,000. The percent that were inside of spec was 99.7%, and that 3 standard deviations fit on both the high and the low side for performance inside of spec. We know the drawing of process performance would look something like this. All right, so I've just drawn performance based upon the following criteria. Change my pen to be a little thicker here. There we go. And the region in green, 99.7%. The region in red, 3 out of 1,000. And 3 standard deviations fit within spec. All 3 of those are ways to measure the voice of the process as compared to the voice of the customer. Process data compared to spec limits. All 3 of those techniques are great process capability metrics that different audiences would understand well. We added a 4th way to describe this picture of process performance. We said anytime you're dealing with a process in which 3 defects out of 1,000 are occurring, where the percent in is at 99.7% and their 3 standard deviations fit within spec. We could call that a 3 sigma process. We could call that a 3 out of 1,000 defects. We could call that 99.7% in. Or what we could call this, and it was just defined this way, if we can fit 3 standard deviations on the high and the low side within specification, a 3 sigma process, we're going to say that that has a CP value of 1. CP, process capability, metric defined in the 1980s, was defined as being equal to a 3 sigma process. If we drew a different process in which we had not 3 standard deviations that fit within spec, but 6 standard deviations that fit within spec, we'd call that a 6 sigma process. The CP value for a 6 sigma process is 2. CP equal to 2 is equal to a 6 sigma process. How did they come up with that? It was defined that way. It was just stated we're going to start with a brand new metric. We're going to call it CP. We're going to call it 1 if you've got a 3 sigma process. If you've got a 6 sigma process, we're going to give it a CP of 2. And so a new metric called CP was created. They call it process capability. And it compares how much of your process data fits within spec, and the definition is if you can fit 3 standard deviations on the high and the low side within spec, you're operating at a CP of 1. If you can fit 6 within spec on the high and the low side, you're operating at a CP value of 2. Let's now take a look at the difference between this metric CP and another metric that was defined that's very similar, and it's called CPK. I'm going to clean up the board to help us with that one. All right, I want to take a look now at the differences between CP and CPK. First, let's summarize CP again. CP is just another way of measuring the capability of a process, measuring how much of the process fits within customer specification limits. A CP of 1 is equal to a 3 sigma process, or a process that has 99.7% in. And a CP of 2 is just defined as being a 6 sigma process, 99.996% in. And so I've drawn what that looks like in the slide right over here. We've got CP equal to 1. We've got CP equal to 2. What CP doesn't tell you is how close to the nominal dead center between the upper and lower specification limit are you? It just compares the width of the process curve to the width of your specification limits. So in this first example that I circled in red, we've got a CP equal to 2, very skinny curve as compared to our spec limits. But now let me change my pen. In this example in blue, we've got a very skinny curve as compared to specification limits. It would still have a CP of 2 because CP only measures the difference between the width of your process performance curve, your historical data, to the width of your spec limits. It doesn't also consider how close to the dead center target are you. That's where CPK comes into play. CPK is measuring the width of your process performance curve to the width of the spec limit as compared to the nominal dead center target. So, new colors here. Earlier in our blue example, we said this is an example of CP equal to 2.0. This is an example of CP equal to 2.0. But clearly there's a difference between the two drawings. One is way off center. The one that is dead center, we give a CPK value of 2. The one that is off center, the CPK value is going to be much lower. And in a moment, I'll show you how those numbers are mathematically calculated. But in theory, when you've got, and just theoretically speaking, if you've got CP equal to CPK, it means that you've got a process that is very well centered. When you've got a situation in which CP is greater than CPK, that's an indication that you've got an off-centered process where the process performance curve is probably not at that nominal dead center target. Now let's take a look at how we actually mathematically calculate CP and CPK. I brought this slide up primarily just to show you that the calculation of CP and CPK just doesn't come magically out of thin air. We take a look at each data point and we compare it to our spec limits. There's a lot of effort involved with that if you're dealing with hundreds or thousands of data points. And so rarely do we ever calculate CP and CPK manually. We almost always rely on statistical packages to calculate the results. And when the packages calculate the results, frequently they'll show you your CP value, your CPK value, and your sigma level of performance, and quite frequently your defects per million your DPMO or defects per million opportunities, all right next to each other side by side, because they're all related. They're all comparing the voice of the process to the voice of the customer. They're comparing process data to the spec limits. And so let me pull up a table that does a comparison of different CP, CPK, and sigma levels of performance values. All right, I know that table is a little bit hard to read with all of the data in it, so let me just zoom into the top part here. Bring up my pen. And what I wanted to show you was if you calculate a CP equal to 2, that's the equivalent of a Six Sigma process, and just about DPMOs of about 2, technically 3.4 defects per million opportunities, and so on. If we had a CPK of 1.33, that would be the equivalent of a 4 sigma process and about 6,000 defects per million opportunities. If we and we could continue on through this. The software calculates it for us. We can look it up in tables, but they're all related. They all compare the voice of the process to the voice of the customer. But in the end, if you've got CP and CPK values that are equal, you know you've got a process that is centered. If CP is greater than CPK, you've got a process that is off-center. Your typical CP, CPK values are between 1 and 2, which is the equivalent of 3 to 6 sigma level of performance, which is the equivalent to, because CP and CPK are frequently used as performance metrics for tightly controlled processes, it's typically not a metric that I'm using for human-facing or highly variable service-related processes, where these levels of performance are near impossible to reach. I'll use other techniques like our percent in, percent out type scores. And for additional information on CP, CPK, as well as demo examples, I've got some other videos that we can take a look at next.